Alright, do you want to explore the state-of-the-art of battery innovation and the research on vehicle-to-grid and e-mobility? Come in to find out. Alright, Michael, thank you very much for taking your time here at the Advanced Battery Power to
Thank you
talk
very much
about.
for having me.
Yeah, you're welcome. You're welcome. Yeah, today and together we want to talk about battery characterization and giving an overview of what are the different cells that are out there, because you have a very performative and interesting platform with Batemo. But before we jump into today's discussion, let's talk about your path into the field of batteries.
Cool. So yeah, it started a while ago when I was studying electrical engineering at KIT,
Mm-hmm.
and I think my first contact with batteries was when I was a student assistant back then and then analyzing impedance spectra.
Mm-hmm.
So that shaped my research interest also later during my PhD, and that was great time back then.
Yeah. Okay. So how did the path then evolve? So what was the way into Batemo?
Well, after that, I think I went to North America. I worked for Robert Bosch in the Research Technology Center. Back then, I was developing state and parameter estimation schemes for battery management systems,
Mm-hmm.
which got very much deep into controls engineering. And then for my PhD, though, I went back to Karlsruhe, back to the KIT, and then I focused strongly on impedance modeling, impedance characterization of lithium-ion batteries, especially for the low-frequency regime, understanding the electrolyte and solid-state diffusion of these batteries.
Okay.
And after the PhD, I founded Batemo together with my good friend Jan Richter.
Yes.
So the two founders back then. We bootstrapped it. We stayed in an apartment for 1 year and with no income and just developed our modeling solution. And now we're here.
Yeah, it's a really thrilling story, and we're now going deeper into it, right?
Yeah.
But before you explain a little bit what you do in detail, give me the elevator pitch, please. What is your key innovation?
Our key innovation is we are digitalizing the battery system development by providing highly accurate, valid physical cell models.
Mm-hmm.
That's what we basically do.
Yeah.
So customer give us a cell and we deliver back the cell model for the cell for system development, fast charging, and so on.
Okay. And besides that, you kind of use the don't want to call it scrap data, but use the data to build up a kind of second business model, which is I think you also the reason why many of you know actually, and it's quite a good marketing inside, right? So please also explain what the platform is about.
Yeah, sure. So, I mean, it arises. You call it scrap data. I wouldn't call it like that because actually it's validation data because we use that data to validate our models to prove to our customers that the models are valid in a wide operational range from -20 degrees C, like huge 4-5 C discharge rates, up to like 70-80 degrees C, whatever you want to do. So global validity is the point. And so therefore we create the data, and at some point we realized, wait a second, we're sitting on a lot of data here.
Yeah.
So then we decided to first of all to publish some part of that data for free on our website. You can see it now. It's the Batemo Cell Explorer. I think that's what you're referring to. And then over time, people start asking us, "Don't you have more data than what you published here?" And they say, "Yeah, we do have much more data actually." And good idea. And then we decided last year to create the Batemo Insights platform, where we basically publish all the data, make it available as sort of a software as a service, a subscription model, basically.
Yeah, and what is the service comprised of? So what do you offer there?
Yeah, so basically we offer. On the technical side, we offer two things. We offer data, so cell data, meaning electrical data, chemical data, thermal data of the cell. So you can really do cell-to-cell comparison. You can use it for cell selection, cell benchmarking or pre-benchmarking, no matter depending on how deep you want to go. And because that data is so comprehensive and it's so clean, let's say, and it has been measured on the same measurement systems, every cell on the same system with the same procedures, with the same definitions. It's completely comparable on a level of 300 cells, complete comparability. So that's why you can basically study the market. You can see where technology is going. How good is sodium versus LFP right now?
Yeah.
And every week we're adding new cells there because our regular business, the modeling business, requires us to basically. And
Yeah, okay, so because you touched on this, so let me ask the question:
Mhm.
How good is
Sure.
LFP in comparison to NMC in comparison to
Mhm.
sodium right now? What
Yeah.
are the
Yeah.
different trends that
So,
you see?
the cells we see on the market right now is mainly sodium cells with layered oxide cathodes,
Hmm.
and these are right now already comparable with respect to power capability to LFP cells.
Hmm.
So basically, they're yeah same good. And however, the LFP is still better with respect to energy density. However, what we see is that basically the sodium right now is on a level where LFP has been 3 to 4 years ago.
Yes.
And then LFP was strongly improving, and we see already tendencies, basically by looking at the new cells coming up, that also there is a strong slope. So my guess is that within the next like 3 4 years, the sodium will catch up to be at energy-wise to be at the
Mm.
level where LFP is today.
Mm. Are there any names to drop, or any? I mean, always the question how dominant the Chinese are on the market. I assume, of course, they will probably lead the game on this, but are there also other companies, maybe even from Europe, where say like, yeah, there are some emerging trends, some good performance metrics. I know you benchmark the V4 Smart cell, for example,
Hmm.
not on sodium end, but
Yeah, yeah.
nevertheless a
Hmm.
success story from Europe, I think.
Yeah.
So do you have anything to share on that end from the sodium perspective?
From some perspective, um, I see dominantly manufacturers from China.
Mm-hmm.
Today was actually a nice talk here in the conference about Tiamat.
Mm-hmm. Yeah, I also
It's
saw that.
not yet in our database, so it goes out now to Tiamat,
Yeah,
provide us with
yeah.
cells, and then we're happy to test these cells and benchmark them.
Mm-hmm. Yeah, cool. Yeah, we'll have the battery expedition going to France soon,
Hmm.
and we'll visit them as well. I also have a talk with them today,
Hmm.
so I can transport a cell back to Germany
Perfect.
then.
Do so. We need five.
5, okay. Yeah, I mean statistics, right?
Yeah, exactly.
Okay, good. But then because we were talking about the conference, and I would like to touch a little bit on your talk and
Mhm.
do a kind of deep dive. What are you working right now?
Mhm.
And yeah, please enlighten us
Mhm.
on what the trajectory of Batemo is at the moment.
Yeah. So basically, our new product is that Batemo Insights platform
Mm,
where people do benchmarking with, and that led us to giving a talk about, in general, about benchmarking. So what are the different levels of benchmarking, and how can you possibly do benchmarking according to which question you have?
mm,
So the data-driven benchmarking, which we enable with the Batemo Insights, is a very nice way to get quick and, let's say, not cost intensive, quick and cheap answers basically.
mhm,
So you can then compare cells based on their energy density, on their power density, on their resistances, on how they heat up. So
mhm,
all these like very basic characteristics of cells you can directly compare to each other. It's
mhm,
very quick, very easy. Nevertheless, you might have questions which are a bit more complex. So let's say you want to find the best cell in order to drive a racetrack. So what you are interested in the end is not the resistance of the cell. You don't care. In the end, you are interested in how fast can I go on my racetrack.
mhm,
So you're decoupling basically the cell from the KPI you're looking at.
mhm,
You're having a cell on a cell level, and you have a KPI on the system level, and there is some gap in between, right? So it's not easy to assess by just measuring a cell in the laboratory. So if you want to go experimentally, you would have to really like set up a module prototype or something, which is way too expensive and takes too long. And the proposed solution is to do that then simulation based.
mhm.
And the models we provide are just suited for that
Yeah.
because they are generally
So
valid.
you're building on
Yeah.
the cell measurements, and then you're
Yeah.
building up upon this
Mhm.
experimental data,
Yeah.
a model that is simulating the system
Um,
characteristics, or
One step in between. So we are in our laboratory. We're getting cell data, so
yeah,
parameterization data of the cell. We're
yeah,
opening the cell, getting
yeah.
everything
You're
out.
feeding that in the model,
We're
right?
feeding that. We're parameterizing a model with that. We
Mm-hmm.
validate the model,
Mm-hmm.
and then we have a validated, highly accurate model of a single cell.
Yes,
And then we take that model, we build up a system model
that's
using
what I
that
mean.
cell,
Yes, yeah.
exactly. And then on the system level in the simulation, we get the KPI we're actually looking for.
Mm-hmm.
And
Yes.
once you have that, it's super cool because you can just plug and play. You have the system model, you just plug and play cells in and out, and you can then quickly assess the system level KPI for different
Mm-hmm.
cells. That's the basic idea.
Okay, okay. And who is the customer of this at the moment? Is it the automotives? Is it the you mentioned
Hmm.
motorsport, like the who really wanna
Hmm.
wanna tweak it to the optimum? Because you get a lot of information from your
Hmm.
cell modeling already, right?
Yep.
And now optimizing the system level as well.
Hmm.
I'm just trying to get an understanding on what is to gain. Like maybe you
Hmm.
can explain this a little bit. Which
Yeah, of course.
customer can gain what aspect
Mhm.
on
So
from
it's
this?
definitely OEMs. It's
Mm-hmm.
definitely customers doing race applications. They're using that, and the main thing is that imagine you have a cell and you want to optimize its design,
Mm-hmm.
and you're optimizing design looking at cell level KPIs. You might be working with the wrong screw.
Mm-hmm.
Basically, because we've seen that people are making high efforts to optimize the fast charge capability of the cell, like making the active layers of the anode very thin and everything, be super good there. And in the end, on system level, it's not the cell which is limiting, not the anode potential which is limiting the fast charging, but the heating, and because the cooling system is not dimensioned correctly.
Mm-hmm.
So you need
Okay.
to so
Okay.
you need to look at the whole chain.
Yeah.
Otherwise, you might
Mm-hmm.
have a lot of friction in your process.
Yeah. So cooling design, system design, are these the main levers that you see in optimization at the moment? Or because you mentioned about the key
Yep.
metrics, like what are the key metrics and
Mm-hmm.
what are the levers that are influencing them on the
Yep.
system level?
What I see is basically to think the development process as a propagated development process, where you basically develop all along the whole chain, everything in parallel. So
Mm-hmm.
basically, you do a cell design, and then from that cell design, you already get a digital prototype,
Mm-hmm.
a digital twin, and then you take the digital twin and you give it already to the guy making the thermal management system. You take it to the guy who makes the fast charging,
Mm-hmm.
and so from moment number one, all these guys can judge how good that cell is for their application, instead of making a design, producing a prototype, measuring the prototype, making an Excel sheet, giving the values of the Excel sheet to the guy, he trying to figure out something from these numbers, right? So
Mm-hmm.
you make that everybody can work with the same thing,
Yeah.
and
Yeah.
and then in parallel you get feedback, and then you can improve your design using the feedback from the guys building the system. And
Yeah.
I think that's where Europe can be very strong, like in these highly knowledge driven, highly digitalized processes.
Mm-hmm.
Because building the best cell itself, I don't know if we can still get there, because if I see what's coming from Asia, I mean, these cells are really good.
Yes. Yes.
But in thinking the whole package together, like this whole system design, starting with the cell, that's something where Europe can maybe still
Uh-huh.
catch up.
Yeah, I mean, and then this also ties in with the existing competences, also automotive. You mentioned
Yep,
OEMs, right? We're good on the system level. We're good on assembly and stuff
exactly.
like that. We don't have the heritage in the electrochemistry and production on mass scale. Yeah, the reason why I built this campaign is not to be on par with the Chinese, of course. No,
Mm.
I think we need to have a good diplomacy with them.
Yep,
To have an eye level
of course,
exchange,
of course.
but therefore we need to have some level of technological sovereignty,
Hmm.
to know what we're talking about,
Yep, yep.
right? And this is kind of what I try to motivate. Yeah, and I think you're doing a great service on also giving us an understanding where we are and where this inspiring industry is taking us
Yeah.
and our society as such. With that said, what do you see? Because I ask three key questions to all guests in
Hmm.
this
Yeah.
expedition, and in terms of the challenges that we see in Europe,
Hmm.
right? You have the good perspective with those 300 cells
Hmm.
and also access to OEMs, etc. What do you see as challenges holding Europeans back, like building the ecosystem here?
It's a good question. Mm, I think underestimating the complexity of building cells.
Hmm.
So I think we have a lot of knowledge in mechanical engineering in Germany, building like these combustion engines and stuff, and
Yeah.
everything must be super precise. And I think people think then, oh, this is just building a machine which produces the cells. What should be so
Yeah.
difficult? But like when you look at it from a chemistry perspective, there's so many process parameters you need to so tightly control all the time, and you need to be not able only to control them, but to be aware that they are there.
Mm.
And I think the problem is severely underestimated, and that's what we see then, that all these big ventures, they're having huge problems, and they fail basically in the end.
Yeah. They just they have a model. Like you mentioned, right? They have a model, but they're not having all the variables in the
Yeah,
model.
exactly.
Yeah. But still, we are in Europe. You're building a business in
Hmm.
Europe, me as well, and many of us keep innovating here as well. So,
Yeah.
what is the potential that we can leverage on for the European battery
Hmm.
ecosystem? What gives us hope to continue?
I really think to have a very good design of the battery,
Hmm.
and which takes into account how the cell is later being used in a system. So thinking the whole development chain, basically.
Mhm.
Our competitors might be good in building such cells itself. They are good when you look at the cell. But in the end, the cell itself is not interesting to the customer. The customer want to have a product which runs fast or charges fast or
Mhm.
something. And so in the end, the customer value is generated not only in the cell itself, but in the whole system. And I think to get barriers down between departments, to make the development process going through easily,
Mhm.
having nice interfaces in between the different tasks, that's where we should look at, and there is our strength.
Okay. Yeah, I see your point. Final point.
Mhm.
If you would have one advice for industry to get ahead with the European battery ecosystem,
Mhm.
to politicians, investors, peers in our field, what would it be?
Consequently, digitalize your development processes and look at the whole system and not only at the cell.
Okay. Michael, thank you very much for the conversation. It was very enlightening,
Thank you.
and I'm looking forward to see more benchmarks.
Cool. Thanks so much.